It's a sine graph. So the way to remember sine is that its parent function starts at the origin, goes up, comes down. This is pi. This is 2 pi. And then there's points in the middle, pi over 2, 3 pi over 2. This is positive 1. This is negative 1. Is that all sort of clear-ish?
Yeah.
Okay. Same with cosine. Cosine starts high, goes low, reaches a min, comes back up. This is pi, this is 2 pi, pi over 2, 3 pi over 2, like that. We'll get to tangent in a moment. So this starts everything. So you have to have these down. There can't be any confusion about this. There's no way to do these problems without that. So the first types of problems that I see here, besides the matching problems, which maybe, I guess you're just getting into this. Yeah, okay. Trying to decide here how we're gonna do this. All right, let's look at like 9. And we won't do the matching thing, but we'll talk about how to actually graph this. All right, so this has a period. I'm sorry, it has a phase shift.
Mhm.
Do you know what I mean by that, or do you what is the phase shift, if you know?
I know what a shift is, but I don't know what a phase shift is.
So phase shift means horizontally.
Okay.
So is this right or left? And it's the same as, like, imagine this was like x minus pi over 4 squared. Is that to the right or to the left? It's the same rules.
The right?
Okay, so right and how much?
Pi over 4.
Pi over 4. Is this like really different than what you've been doing? Like, am I starting off in a really weird place, or is this consistent with what you guys have been
Um,
doing?
it's what we're doing to a certain extent.
Okay, because based on your answers, I either think that I'm really off, or you like I'm doing a bad job, one or the other. What can I do to make this better for you? Do you want us to start with like period changes first, or phase shifts?
Yeah, I was
Okay.
wondering if we can cover the basics first and then go into problems like this, so like makes a bit more.
Okay. Yeah. So that was the, yeah. I'm just going off the group you sent over. So the first thing would be like y equals sine 1/2 x. That's kind of your most basic type of change. All right. Do you remember what the period is for a sine or a cosine?
The period is 1 second. 4 pi.
Yes. So this is 2 pi over b over 1/2, which is 4 pi. So the reason the period is so important is it tells you how far out you need to go on your graph. So I'm going to call this now 4 pi, which means that that's 2 pi, and then you have to find the midpoint of each. So you always go out one period for sure. Sometimes you got to go out two. We'll talk about that in a moment. So for a sine graph, it starts here, goes up, comes down, comes up, like that. Is that okay?
Yeah.
Now your book and some teachers on exams, they say 2 periods. So you basically repeat what you just did. You just go out another period, which in this case is 8 pi, because it's 4 pi plus 4 pi. You have to find the midpoint again, 5 pi and 7 pi, the next midpoints. They are grading you based on labeling these, so you really want to make sure you do a good job of making those clear.
Okay.
And then you go up, down, down, and up, and it would look exactly the same as before.
Okay.
Is that okay?
Yeah.
So let's do one with cosine. Let's see, y equals cosine 1/3 x. Okay, so what would the period be for this one?
6 pi?
6 pi, yeah, 2 pi over a third, which is 6 pi. So this time when you graph it, you go out 6 pi, 1, 2, 3, 4, 5, 6. You find the midpoint, 3 pi, and then the question is, well, what do you do in between? Well, it kind of depends on what your instructor's okay with. Like I'm okay with 1.5 pi and 4.5 pi. Your instructor may prefer 3/2 pi or 5/2 pi. You have to check with them. But the shape is what we're looking for. Starts high, goes low, reaches a min. Sorry, that's wrong. Reaches a min, comes back up like that. If you had to go out another period, you would go out another period.
I think my teacher only needs 1 period, so
Okay, it's good for now. So let's go back to sine. Let's say it's a sine of 4x. What would the period be this time?
1/2.
It's 2 pi over 4. So it's pi over 2.
Yeah.
Okay. So this time we've got to go out pi over 2. Now what you're going to notice about my graphs is that they all sort of look the same because I don't try to scale them or anything like that. I just go out to where I think that is, cut it in half, pi over 4. This is where, it could be challenging because you may not be comfortable cutting fractions in half. You're dividing by 2. You're then finding the midpoint between pi over 4 and pi over 2, which is 3 pi over 4. Sorry, that's not right. 3 pi over 8. Is that okay?
Yeah.
All right. So then we just graph the same thing. We say, okay, sine, like that. All right. So if you feel like you have that down, I think you do. The next thing we do to introduce sort of complexity is we add something in front here. We change the amplitude. And you notice I keep switching back and forth between sine and cosine. That's just so you keep getting a flip here. Let's go 2 cosine uh, pi. Okay, so I made a couple of changes here. What is the period for this?
2?
2. Yeah, 2 pi over pi, which is 2. So this time you go out 2. That's 1. That would be 1/2. That would be 3/2. And the parent function looks like this. At 1 and -1 goes down, comes up, goes down, comes up like that. What do you remember from class what this 2 does?
The 2 the amplitude?
So what does that do? You remember? And you can
It
always go back
says
to
the
like,
Y value, pretty sure.
yeah, it's a vertical stretch. So all the Y values are multiplied by 2. And I tend to switch colors now. So instead of it being at 1, it's now 2. This point goes up to 2. 0 stays the same because 0 times anything is 0. -1 goes down to -2, 0 and 2, like that.
Okay.
Okay, Akshara, so we're back to we're gonna do a sine one now. Like getting the feel of this. 3 sine, let's go 1/5 x. So give me the period, please.
2/5 pi.
It's 2 pi over 1/5. Try that one more time, please.
Oh, sorry, 10 pi.
10 pi, yeah. You tend to see either a fraction in front like this or a whole number-ish thing. They can be made very difficult, but I'm trying to keep them reasonable. So again, you always start by drawing the parent function here. So you got, I'm gonna go out again. I'm just gonna go out like, okay, I'm gonna call that 10 pi. So that's 5 pi, 2.5 pi, 7.5 pi. And so sine starts at 0, goes up, comes down, goes down, comes up. What does the 3 do?
The amplitude,
Yeah, what does the amplitude do? It's just like the last problem.
the y value. Like how high or below you go.
It stretches it, yeah. So it stretches it. So 0 stays the same, but this point right here goes up. Instead of being at 1, it's now at 3. 0 stays the same. And so you get something that looks more like that. And I'm going to do it on this graph. What would a negative out in front do? What do you think?
Reflected.
Over which axis?
X.
Yes. So if it's up here at the top, it's going to come down below. If it's down at the bottom, it's going to come up. The 0 points stay the same, so that comes down. It's like that. And you can see how quickly it gets pretty messy. I like colored pencils in this part of the course. If you have them or like them, I would do that. You may also consider redrawing your final answer. You may want to like almost, just to be helpful for your instructor, so that you maximize your grade, that you redraw it, or if it ends up being the one that's the other direction, you go that way. That way you've got kind of a final reasonable answer there. Is that okay?
Mm-hmm.
All right, so I'm gonna give you a couple to try here. Let's go y equals negative sine 8x. Go ahead and try that, please. And I will graph it, but give it a try. So what I'm grading you on are it's the period, the all the tick marks on the x-axis, the shape, and then like any flips, things like that. So let me know when you got something down.
The period is pi over 4.
It is it's pi/4. Good.
What's the t pi x-axis shape?
Oh, just keep this is just so you knew. Like what I'm looking for when I grade this is like, do you have the right numbers along here? Does it have the right shape? Does it go the right
Oh, okay.
way? Yeah. Sorry, it's terrible writing. I'd like you to make a graph. I won't be able to like look at your graph, but you can make one and I can make one and then you can tell me if it's the same.
I did the tick marks pi over 8 and then pi over 4. And then I started at the origin and I went down to 1 and
What
then
I want you,
back.
yeah, when you've got a full graph, I'll graph it as well. That way you can check and see if it's the same.
Yeah,
You don't
I
have to
finished my.
okay, yeah, you don't have to show me your graph. I yeah, I was just trying to make sure that you sorry, you said pi over 4. Yeah, pi over 4. This is pi over 8. This is pi over 16, 3 pi over 16. And then yeah, it goes down, comes up like that. Something like that. If your graph looks like that, really should label the x-axis, I'm the sorry, the y-axis as well. But that's great. All right, so let's have you try another one here. Sorry, let me do this one. Pi over 4x, like that.
Is the period 8?
2 pi over 4 becomes 8. Yes. Yeah, very important that you get that down.
So would we just do like intervals of 2 for x? Or
Yeah, that's right.
so it'd be 2, 4, 6, 8? Or
Yep, that would be good.
I think I did it.
Okay, let me check you here. So like you said, yeah, call that 8, 2, 4, 6, 8. Cosine normally starts high, but because of the flip and the 2, it's actually going to be down here at -2, +2. So it's going to look like this, something like that. Is that what you have?
Yeah.
Great. Okay, so the next way to increase the difficulty is to add a vertical shift. All right, so let's just say on this one I added a +1 here, and we're doing the order you would need to do it. Every point moves up 1. So this one truly affects everything, like that.
So could you just add the two, -2 and the 1, or would that not?
No, you do not. They're not like terms.
Okay.
So that's that one comes at the end. So you do everything else and then you shift it. All right, so let's start with, let's kind of go back to basic. Let's say it's like sine, uh, let's see here, like 6x plus 1. Okay. What would the period be?
Pi over 3.
Pi over 3, yeah. So you graph this just the way you normally would, which it gets weird when they're not nice numbers. So that's also a thing your teacher could be checking you on, is like how comfortable you are, cutting these in half and then, getting the next ones if you even need it. So uh, keep that in mind. And then the plus one, I like to graph the parent function first, and that's only when I will then add the vertical shift.
Okay.
Okay. Let's have you try one here. Y equals minus cosine x plus 2.
I think I did it.
Okay. So I would always tell you to graph the parent function, even in a simple example like this, just so you've got kind of the basis of it. So the negative flips it, right? So it starts here, and then the plus 2, every single point in red goes up 2, and I'll switch to a new color for that. But it's got the same shape. What did I miss here? Sorry, there it is. Got the same shape like that. Does that kind of look like your final answer?
The black one, yeah.
The black one or the blue one? Because you have to flip
The
it and then go up 2.
Yeah, so it'd be the black one, right?
Well, okay, so let's back. The black one is the parent function. The negative, the negative is the flip of it. Then, then you can go up 2. So every point goes up 2, like that.
Oh, okay.
Is that okay?
Yeah.
Right. Let's try another one. why don't you try graphing this one?
I think I did it.
Okay. All right. So again, I'm trying not to do any period changes just because that gets pretty it adds to complexity. But that's the parent function. So this time the negative flips it like that. It's kind of a cool look. And then the +3, every single point goes up 3. You can just count, in some cases like that, but you get something like that. Does that look good to you?
Yeah.
Okay. All right, so that's kind of the basics. The full kind of everything is where I throw in a period shift and an amplitude. Um, Something like that. So give this a try. Take your time. Really, you really want to do it. Okay, period, parent function, then amplitude, then flexion, then down. So you might have as many as 4 or 5 graphs, like it's kind of normal. So if you write with pencil, you may want to write lightly, or you may, want to get good at erasing.
Yeah.
I'll be right back with you. I am back if you have any questions.
Um, I think I did it.
All right. Let me go ahead and kind of show you the steps here. I mean, that's kind of the idea here. What is the period that you got?
The period is pi.
Pi, good. So that's pi. Is that pi over 2? That's pi over 4. It's 3 pi over 4. Okay, so the cosine, the parent function, looks like this. Okay,
Hmm.
hang on just a second. Okay, sorry. The next thing is the 2. So it's gonna pull it up, pull everything up to 2 there and down to -2,
Hmm.
like that. All right. And then it's a flip over the x-axis. So this flips down here. And see how it gets really, really messy, right? And then down 1, everything moves down 1. I mean, I've got the advantage of having all these different colors, but you can see it gets pretty bad. Does your final graph look something like that?
Yes.
Okay, that's great. That's really good. So that's kind of the most challenging question that you can see until we add in what's called a phase shift, which I would like to avoid talking about for the moment. I'd like to work on some other problems. Um, there's a couple of little things that we need to make sure that you know about, and then there's kind of working backwards questions. All right, so here are a couple of problems for us to look at. Okay, 19 here. 19 says y equals 3 sine 2x minus 4. So the first thing it asks you to find is the period, which you've been doing really well at, but you have not had any problems like this. What you do want to do is actually factor out whatever numbers in front of the x to start. Did you guys talk about that in class? Yes, no, maybe.
Uh, kind of
Okay.
like
So you
one of the
always
practice
factor,
problems.
yeah, whatever's in front of x, you always factor out. Then we'll get to some more complicated one.
Okay.
The next thing here is the period is always 2 pi over b. This is b. B is the number in front of x, but it's really the factored out b.
Pi.
2 pi over 2, which is pi. Good. The next thing, believe it or not, is the phase shift, which we really avoided talking about, but you have to factor it out like this. All right, so the phase shift is 2 right, 2 right. The reason it's 2 right is because of this 2 in here. It's just like the quadratics. It's just like the left, the right. Um, it's just like that. So the the next the um it's not this 2, it's the one inside here. The amplitude is the absolute value of the number in front. Now it just happens to be the number in front, but doesn't, if it's -3, the amplitude is 3. This one has no vertical shift because there's nothing on the outside here.
Mhm.
Okay. Is that all right so far?
Yeah.
Okay. So let me give you another one to try. And the have you do the same thing, find the period, the phase shift, the amplitude, and whether it's a vertical shift. Sound okay? All right. So let's say
Okay.
it's y equals -5 sine 5x minus 5 plus 3. So I'm looking for period, phase, shift, amplitude, and vertical shift.
The period is 2 pi/5.
Okay, very
The
good.
phase shift is 5.
5 right or 5 left? That's important.
Oh, 5 right.
Okay. And the amplitude?
The amplitude is 1 sec. 5,
It's
but
the
it's
opposite value of
reflected.
negative. Yeah, you don't have to, that's not typically part of this sequence. They usually don't write, don't include that for whatever reason, but
And then the vertical shift is up 3.
okay. Um, Sounds good. All right. Do one more. Let's go cosine. Right. So one more free to try here, please.
Do you want me to list all the things and then
Yeah, yeah, same
graph?
list. Sorry, I can list it too. Period,
The period is
phase.
2 pi/3, and then the phase shift is 2 to the right, and the vertical shift is up 1, and
All
then
right, so
the
hang on,
amplitude is.
hang on. Did you factor 3 out of both? So this one's different than the previous one. Like it's oh, and I actually let you talk me into that. This is 5 times x minus 1 in parentheses. This is actually only 1, right?
Oh,
You have to factor
would
that
the
number out.
period still be?
Yeah, the period's still over this number here, b. So this one here, you want to factor the 3 out of this. So like what goes in here such that when you multiply in, you get back to 2. It's like divide and slide kind of thing.
2 over
This is
3.
2/3, yeah. So the phase is 2/3, right?
Mm-hmm.
This time. What about the amplitude and the vertical shift?
The amplitude is 4. The
Okay,
vertical shift is down 1.
down 1, yeah. All right. So I think you've got the hang of it now. Let me have you try one more. Nah, actually, I think you got it. All right. So the next grouping of problems that we're going to look at are going backwards. We got a limited amount of time to do this. So this is where they give you the graph and you have to write the equation. So the first thing is to decide whether it's a sine or a cosine. What do you, which one does this look more like to you, a sine or a cosine?
Sine.
I think it's a sine, yeah. So you start by writing like y equals a sine bx minus c plus d. You could write the general format if you wanted. It's probably too much, but that's okay. The next thing is to look for the period. The period in this problem is 2 pi. That's start to finish kind of that it gets back to the same point. But that's not the b value. The period is 2 pi. That's 2 pi over b, so you have to solve for p in this equation. Did you see that in class?
Yeah.
Okay. So in this case, b would be 1, which is good. Um, is there any sort of horizontal shift? Does this thing move to the right or the left or anything like that?
Is there any what?
Horizontal shift, phase shift. Like, does it look like the sign has been moved to the right or to the left? Maybe you're not sure. So I have the advantage of sliding this up to where it started. Does it look like it was moved right or left or not at all?
Oh,
This has not been moved at all. This has no phase shift, which means C is 0.
okay.
All right. The A value is the max minus the min divided by 2. Okay, so the max value of the original is 0. The min of the original is minus 2 divided by 2. So this ends up being 1. That's the value of A, kind of. If it's reflected, then you have to apply a negative sign, but that we'll get to that at some point. D, D is the max plus the min divided by 2. So this time it's 0 plus negative 2 divided by 2, which ends up being -1. So if you notice here, the whole goal here is to find the values of A, B, C, and D. We found them. They are 1 sine 1x minus 0 plus -1. And you do simplify, so it ends up just being sine x minus 1. And maybe it's easier to say, oh, it's a sine wave shifted down. Well, it is, but this is the progression that you're supposed to go through.
Okay.
All right. All right, we're pretty much out of time. This is a really tough topic. I don't know how well I did tonight, but